Hello, this is Dr. Kayla Kaiser at California State University Northridge. We're going to be talking about the calorimetry experiment for Chem 101. Make sure that you start the experiment by preparing your water bath. You want to have 200 milliliters of DI water, and the lab manual says to put it on setting 5, but in our experience that took way too long, so please put it on setting 8. We're going to be determining the heat capacity of 3 different materials: aluminum, stainless steel, and copper. You can tell which one is the aluminum because it's less dense and it's much larger. The stainless steel and the copper are the same size. You can tell which one is the copper because it has a reddish color to it. And you're going to be issued 2 calorimeters per group. You're going to be working in pairs. One calorimeter consists of 2 nested coffee cups, a foam lid, and a thermometer. But when you get the mass of the calorimeter, you only need to weigh just the cups together. The tongs are also very important for this experiment. So you're going to go to the balance. You're going to make sure that it's reading 0. You're going to make sure that you record all of this information in your lab notebook. You're going to take one by one the pieces of metal and put them on the balance pan. This is the copper. I'm going to go ahead and wait for the reading to stabilize with the door closed, and then I'm going to write down the mass of the copper. And what I learned is that all 3 of these pieces of metal have a mass close to 30 grams. So if the balance is not reading 30 something grams, you might want to make sure that the balance is zeroed out. And I did the aluminum second, and now I'm doing the stainless steel third, and this one was 29.8 grams. Make sure you write down all of the 4 digits after the decimal place. Do not use the top loading balance, use the analytical balance. The next thing you want to do is get the mass of the empty calorimeter, and your cups may or may not already be labeled. For example, this one has a number 1 on it, and the next one has a number 2 on it. If your coffee cups are not labeled, make sure you go ahead and just write a number on there. And because the masses may be different, mine were approximately 5 grams each, so if the balance is not reading 5 grams, that may be something wrong with the balance. Next, the task is to weigh out approximately 70 grams of water. If you put that on the balance and it reads just like a flat line straight across, that's because the balance only goes up to 100 grams. So you're going to have to dump out some of the water until the mass of your coffee cups and the mass of your water together is not more than 100 grams. So I think I probably used about 75 milliliters of water. That's fine. Let's say you wanted to use even less than 70. That's also fine. The main thing is you want to make sure that the thermometer reaches all the way down into the water when you have it assembled with the calorimeter, and that there's enough water to cover the larger piece of metal, which is the aluminum. That cylinder was a little bit tall. The most dangerous part of this experiment is most likely when you are dropping the metals into the boiling water with the tongs. So be very, very careful when you're placing the metal into the beaker of boiling water. So you're going to place all of the metal pieces into the water bath once the water starts boiling, and then you're going to let them come to thermal equilibrium for 10 minutes. Don't forget to record observations in your lab notebook as you're going along. Remember, there will be questions about this on notebook quiz number 2. You can't hear it in this video because I have the sound turned off, but the metals were making quite a lot of noise as gas was leaving the solution. The metal pieces were acting kind of like a very large boiling chip and kind of burping. So be aware that it will be noisy, and that's okay. get out your timer and record the initial water temperature of the water in the calorimeter before you add the metal. So make a little data table, start with time 0, record the initial temperature of the water, and then use the tongs to add your metal pieces to the calorimeter. Make sure that both people in your team are taking turns to actually get the hands-on experience for this lab. It shouldn't be just one person doing everything and the other person just watching. So put the metal in the calorimeter, give it a couple of swirls, and then let it sit and read the temperature every 30 seconds for a total of 4 minutes. Make sure you also record the temperature of the water as it's boiling. Our temperature, I assumed it would be around 100 degrees Celsius, but ours was more something like 98 degrees. And don't forget to exchange data with your partner so that both of you leave the lab with all 6 trials recorded. Make sure when you're reading the temperature that your eye level is right at the thermometer level so that you're not getting any parallax error. And do record the temperature to 1 digit after the decimal place when you're writing down those temperatures. Hopefully this video has given you some insight into this experiment. And a special thanks to Professor Daniel Tamai for being my lab partner as we were getting data for this trial.